Section 2.2, Venn diagrams and subsets. Set A is a subset of set B if every element of set A is also an element of set B. Notation we use: A is a subset of B. The subset symbol is a sideways U with a line underneath. Or A is not a subset of B with the line through the subset symbol. Is A equal to 1, 2, 3? A subset of B equal to 1, 2, 3, 4, 5. 1, 2, 3 are all elements of 1, 2, 3, 4, 5. So yes, A is a subset of B. Is B equal 2, 4, 5, 6, 8 a subset of C equal 2, 4, 6, 8, 10, 12? No, because 5 is an element of B and 5 is not an element of C. Determine whether or not the first set is a subset of the second. 3, 4, 5, 6. 3, 4, 5, 6, 8. It is a subset. 1, 2, 6. 2, 4, 6, 8. The second set does not contain 1. It is not a subset. 5, 6, 7, 8. 5, 6, 7, 8. It is a subset. Equal sets. Sets A and B are equal if A is a subset of B and B is a subset of A. Proper and improper subsets. Set A is a proper subset of B if A is a subset of B and A does not equal B. This is written: A is a proper subset of B with a sideways U. Set B is an improper subset of set A if set A equals set B. The empty set is a subset of every set. Is the left-hand set a proper or improper subset of the right-hand set? 5, 6, 7. 5, 6, 7, 8. Everything in the first set is in the second set, but they are not the same. It's a subset. ABC and ABC, they are the same. It is a subset. Use a tree diagram to find all possible subsets A of the set S. The set A has the elements 5 and 6. So let's think. Is 5 an element of A? Yes? No. Is 6 an element of A? Yes. No? As we read across this tree diagram to write our new sets, 5 is in the set and 6 is in the set. Continuing across, that was going yes and yes. 5 is in the set, 6 is not in the set. Reading across, no, 5 is not in the set. Yes, 6 is in the set. No to 5 and no to 6, the empty set. There are 4 subsets, and we listed all of them. Use a tree diagram to find all possible subsets A of the set S. We're going to start it the same way with our two branches for the letter A, yes, no. And then we're going to branch off, yes and no for B, yes and no, and branch off for C. Each one is a yes or no. As we read across, in our first set we have A, we have yes, 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 so A, B, C. Our second set, we read across A, B, no C. Our third set, we read across yes to A, no to B, yes to C. Yes to A, no to B, no to C. Those are our top four sets. Our bottom sets, no to A, yes to B, yes to C. No A, yes B, no C. No A, no B, yes C. No A, no B, no C in the empty set. There are 8 subsets, and we listed them. How many subsets will each set have? Fill in the blanks and look for a pattern. If there are 0 elements in the set S, there will still be one subset, the empty set. If there is one element, given the example, one element, that element is A, it will have the subset with itself, and it will have the empty set 2 subsets. Our example we did with 5 and 6, there were 2 elements in that set, and we were able to list 4 subsets. 3 elements, A, B, and C. We listed our subsets, and there were 8 of them. Looking at the pattern we're seeing, how do we go from 3 to 8, 2 to 4, 1 to 2, 0 to 1? For any number we want, our number of subsets is going to be 2 to the n, where n is the number of elements in the set. So if the number of elements in our set equals k, the number of subsets is 2 to the k. The number of proper subsets, remember that's all subsets that aren't the set itself, is 2 to the k minus 1. What is our number of subsets of S and our number of proper subsets of S? If we look at our first set, S equals 3, 4, 5, 6, 7. There are 5 elements. 2 to the 5th will give us our number of subsets, which is 32. Our number of proper subsets is going to be 2 to the 5th minus 1, which is 31. Looking at our second set, S, there are 1, 2, 3, 4, 5, 6, 7, 8 elements. 2 to the 8th equals 256 subsets. And our number of proper subsets is going to be 2 to the 8th minus 1, which is going to be 255. That's section 2.2, subsets.